Now, the bisection method is, they call it a bracketing method. Okay, bracketing method, in the sense that we get an interval which contains the root, and then we keep on making this interval smaller and smaller until we get a really good approximation to the root, either by using termination criteria, which will include, let us say, we start with a large, a large bracket, a large interval where we have confirmed the root exists, and then we make this smaller, and we keep on making it smaller and smaller and smaller until we get a really good approximation to the root by using termination criteria, which will either we are following a given error, or a given level of error, the difference between the the approximate solution and the true value, or the difference between successive approximations. Okay, if the difference between maybe the solution at step xn plus 1 and the previous step is less than a given level, tolerance set for us, or we can use a finite number of steps as our given termination criteria. Okay, now the bisection method is based on a method it is based on a theorem from calculus, which is called the intermediate value theorem. I hope you remember this from your calculus. Okay, from your calculus you remember things like the IVT, the intermediate value theorem, and related to it also the mean value theorem, and so on. So I will state it here, and perhaps assume that you went through some of these and you can recall what they are. Okay, so perhaps before I get to that, let me just have a quick illustration here. Let me draw an axis here on the straight line. Okay, and then I'll draw this as well. Okay, so the IVT says that if f is a continuous function, f is a continuous function, that is a condition we start with. If f is a continuous function, and we have f of a and f of b, where a and b are, the interval on which we want to find whether the root exists, and f of a times f of b are of f of a and f of b are of different signs, i.e. F of a times f of b is less than 0. The product of f of a and f of b is less than 0. That means they are of different signs. Then at least one root lies between a and b. Then at least one root lies between a and b. Okay, in other words, just to go through this once more, we are saying that if f is a continuous function, and then we want to find whether a root exists on this interval ab, if f of a and f of b are of different signs, i.e. their product is negative, then at least one root lies between a and b. The logic in the intermediate value theorem tells us that if a function is continuous, we know that it is not going to skip any value. Okay, so if this function here is continuous, and then somewhere the value of the function is positive and somewhere else it is negative, then we can be sure that this function at least crossed the x-axis here. it crossed the x-axis, i.e. it has a root, it crossed the line x equals to 0. Okay, I mean it crossed the line y equals to what? To 0. It crossed the x-axis. In other words, this is the root, that it contains at least a root.